We are familiar with thermodynamics, and in thermodynamics we can see the application of divergence. We have source always generates energy and sink absorbs energy. Therefore, we have divergence of source is always greater than 0 and divergence associated with sink will be less than 0. This is because source has outflow of energy from it and sink has inflow of energy to itself. Let us look at an example in which we will compute divergence of a vector as well as curl of the vector, where the vector f equals gradient of x cube plus y cube plus z cube minus 3xyz. We have the scalar function is phi equals x cube plus y cube plus z cube minus 3xyz, whose gradient we will find in order to evaluate f bar, which is the vector function. Gradient of phi equals del phi, which equals I dou by dou x plus j dou by dou y plus k dou by dou z operated on the scalar function phi. That is f bar equals I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. We have dou phi by dou x equals 3x square minus 3yz, dou phi by dou y equals 3y square minus 3zx, and dou phi by dou z equals 3z square minus 3xy. Therefore, the vector function f bar equals 3x square minus 3yzi plus 3y square minus 3zxj plus 3z square minus 3xyk. Now we will evaluate divergence of this vector function f bar. We have divergence of f bar equals dou by dou x of the component 3x square minus 3yz plus dou by dou y of the component 3y square minus 3zx and dou by dou z of the component 3z square minus 3xy. If you consider this as f1, this as f2 and this as f3, we have divergence of f equals dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3. Partial derivative of f1 with respect to x will give us 6x. Partial derivative of f2 with respect to y will give us 6y. Partial derivative of f3 with respect to z will give us 6z. Therefore, divergence of this vector function will be 6 times x plus y plus z. Now let us evaluate curl of f bar. In order to evaluate curl of f bar, which is cross product between del operator and f bar, we have the determinant notation, which is ijk dou by dou x, dou by dou y, dou by dou z, 3x square minus 3yz, which is the component f1, 3y square minus 3zx, which is the component f2, and 3z square minus 3xy, which is the component f3. We have curl of f equals del cross f, which is equal to determinant of this expression. Always we have curl of a vector function equals determinant, whose first row will be ijk, second row will be dou by dou x, dou by dou y, dou by dou z, which are the components of del operator, and the last row will be the components of vector function. We will expand the determinant as usual and we obtain curl of f equals 0. Here we see that the function f is irrotational because we have curl of f equals 0.